Well, hi, good morning. Thank you for joining me here. It's October 30th today, and I'm facing this radio with its string problem, and oh boy. Just before I turned the camera on, I was just looking at it, pondering what I'm going to do here. And one of the questions I had after yesterday's session, while I was thinking about this in the evening, and that is the string fixed to this wheel? Or is it just rotating around the wheel, coming in, go around, and go out? And unfortunately, I think, oh, maybe I'm wrong. I thought I saw a spring. I think I see a spring under here, which means the string is terminating on this wheel, and that means slipping the string on the wheel. That's not happening. So if that's the case, I'm not sure that's the case. We'll look more closely in a bit. You basically have to coordinate two different string systems to get this to show the pointer correctly. Oh boy, I wonder if the last guy restrung this and made a mistake. And I think no, I don't think that's the case. I think that's extremely unlikely. But wow, this is a monster to do. If you wanted to restring this, oh my gosh. Yeah. I'm busily unnerving myself here. I may have better go and take a little break already. It's been not even 2 minutes. I'm taking a break. Okay, I sort of calm myself down and think about this logically. So somehow this radio got into this state. So I need to understand exactly what the state is, for sure. How it could have gotten into that condition or state, and then correct it from there. Yesterday's attempt at slipping the string here, which didn't go well at all. It didn't go at all. That's kind of the danger. The thing I did there that was dangerous is I jumped at my first idea. And we tend to do this as people. First idea comes along, let's get going on it. It's probably better to postpone the first idea until you've got the second and third idea in your head, and then you can make some kind of better decision on what to do here. So somehow it got into this state. How did that happen? What state is it in exactly? Who's out of sync here? The pointer? The wheel? The capacitor? Good questions. Did somebody restring this and make a mistake? Did somebody restring it and get it wrong? They got the strings on correctly, but they got things in the wrong place. And once it's done, you can't, maybe, it isn't easy to correct it. So they cheapened out and just moved the pointer and hope nobody would notice. That's quite possible. I've definitely done string jobs. This looks like a terrifying one. And at the end of it, I have had things happen where you turn the knob to the right and the pointer goes the wrong way because you wrapped it around the spindle here backwards. I've done that. You only find that out when it's all done. And then you got to decide, am I going to undo all this horrendous work and fix it? So perhaps somebody did this, got it wrong somehow, and then just abandoned ship at that point. Or it's something really simple. It's something really simple, like the string has slipped on this wheel. It could be that. It could be as simple as that. Now, so as for there being a termination of the string on this wheel, from this angle I can look at this little punch out that they do on these wheels. They cause a hook to form on the other side. You hook the string on it or hook a spring on it, and I can see the spring end right here, and I think I can see another one. There's another hook spot over here, which means the string is terminating at the wheel, which means there's no slipping of the string on this wheel. This wheel is not actually driving anything at all, but it has this stopper. right now the stopper is all the way. It's pumping in right in here. It means the pointer should be all the way also. And that means the capacitor should be all the way. Okay, I gotta think. I gotta think to myself about this a little bit. Let's take a look at the stringing diagram here, and I can already see that there's nothing I can do here. I'm pretty sure. If you look, let's start over here. This is the big wheel that's not driving anything, the gearing wheel, if you like. You see that the string is terminating here, and this string here is terminating here. So go to the other wheel. This is the one that's right on the tuning capacitor, and the string is terminating here. That means there is no slipping of the string anywhere in this scheme. Stringing diagram, latest production sets. And here's some done just a little bit differently, or they're showing it at different stages. Early production set, later production set, and in every case the string is being terminated on these wheels. Now wait a minute. Now there's two strings. So which string is being? They're both being terminated here. You can see the termination of the outside wheel string and this one. Now is that really a termination, or is that just a pull down of the string? Let's look at this other diagram. See, it's possible the string actually doesn't terminate here. It comes around, and they've pulled it down and connected it to the spring to apply tension at this point. This is slippable here. Except all this is hidden behind the front panel. On taking the front panel off, yikes. That's what I would say about that. Yikes. Why would I take the front panel off? So I can get at this. Because my theory, see this one here, they show some tie strings, like they've tied a knot here. They don't reveal that here. So the other question I had was, how did it get into this state? Well, if all the strings are terminating and there is no way to slip anything, if that's the case, then somebody's redone the string and done it wrong. And the solution, there is no solution except doing it over again. Yikes, yikes, yikes. On the other hand, the string all looks the same. It all looks like it could easily be original. I really don't have any strong reason to think. Yeah, I don't have any strong reason to think. I don't have any strong reason to think anything's been done to the string. So let's suppose nothing's been done to this string on this radio, and somehow it's in the state it's in. How did it get there? And am I understanding the state properly? Maybe there's nothing wrong, and I've just gone and befuddled myself with this. Yeah, let's review again what I think is wrong with this. So what I think is wrong with this is this wheel hits the stop bumper where it is right now. It cannot be turned any further. That means this cannot be turned any further, and you can see where it's sitting. It's not all the way. It should be all the way at this point. What happens at the other extreme then, when we dial this the other way? Probably this meets its stop, and that just stops everything at that point. Get a good look at the stopper pin on this wheel. Oh, that's a long journey in this radio to go all the way across. Holy smokes. Okay, so now we run in. So this is hitting the stop. You can see that the string is trying to go further. Looks like the stopper here should be hitting the other side of the stopping block, or whatever you want to call that little piece of metal you see sticking out there. So I think I cannot slip the string here. You can see the string coming around and going down through this opening where it's got to be meeting up with springs or something like that. How can I see in there? Can you possibly see in there? I know how to see in there. I can sort of see. Well, I don't see a spring. It's tied. There's no spring. It's tied here. What's it tied to? There's no. Is it really tied there? Wish I could get a camera back in there. I wonder if I can do that. Let's try. Okay, so this camera, it's got its autofocus on. Just bear with me a moment while I'm going to turn off the very annoying autofocus on this camera. At least it's annoying, probably because I'm using the camera very close up, and the autofocus really isn't intended for that. Okay, so I've focused in just as far as I can. That's probably too far. Let's just go back a little bit. Okay, there we go. I can't imagine this is really going to work out, but let's see what happens. Yeah, I've got the focus way off here. Open wide. Well, you can see the string, but not in focus. Okay, so the focus has to be something like this distance here. Okay, hang on a second. I can't do that. There's got to be times when you're watching my videos you wonder, what the heck is he doing? Because you can't. What the heck am I doing? I'm trying to focus this. Let's try that. We're looking for a spring, or how the just get a little dark down there at the last moment. See the end of the string there, I think. My camera's caught. What's it? My camera. My mirror. it's just out of sight. Oh. Well, I can't see anything. I cannot see well enough. Let me look at the diagram again. Let's look at the diagram again here. Something funny going on. Something a little funny going on my computer. We shouldn't be able to see this right now, but anyway, there it is. And you cannot see. Oh, what's happening? I don't know what's happening. Something is frozen on my computer here, but it's frozen with this diagram in place, and you can see it. So, well, you can see on the wheel on the left side of the diagram, the strings are tied down. There's no spring, and that appears to be what is going on. Yes. Okay. Well, Well, I'm gonna go drink some coffee here, sort out what happened to my computer. Okay, if we go on the assumption that the strings are all correct, you know, we can't go on that assumption. I'll finish my statement here. I started saying to myself, well, maybe the problem really is a very severe alignment issue and the IF has been tuned way off, and that's causing everything to be shifted left or right. And then to compensate, the pointer was put in the best spot possible, and that's the end of that. But that can't be the case because this wheel is hitting the stop. Huh. Ha ha ha. Yeah. a lot of silence here because, yeah, really, how did it get into this? This has to be the case of somebody restringing it and getting it wrong, and then going, F this, and leaving it. I wouldn't be surprised. I think it's possible to get this front panel off, and these supports would remain along with these wheels. At first I thought, well, you can't even take this front off because the wheels will go with it, but I don't think they will. So we could remove the front. And we kind of had to get in and dust this thing anyway, so I think this bezel has to come off in any case. Well, then we go further and take the whole thing off. Then we have all the strings exposed. And I'm on my way to redoing the string. One of them, anyway. And I don't find that to be... that's not something I'm going to jump at. Not on this radio, anyway. But that's a possibility. You know, except that the string is wrong. Which string? There's two strings. The pointer string can't be wrong because it's where the pointer goes on that string that makes it right. So the issue cannot be the pointer string. The issue has to be the capacitor string. Okay, that doesn't make me feel any better. I'm running to my coffee cup now. Since I don't want to jump in and start fiddling with the string directly until I'm absolutely sure that's the only route to success, I'm going to check the IF tuned frequency and just see that it's in the realm of 455 and not 300 or something crazy like that. I don't know how it could it even be that far out. I don't think it could be. Obviously, there's a limit to how far you can move the slug in these coils, and okay, doesn't have to be 300 to get this inaccurate on the front here. So I've got my signal generator going there. You can see it's 468. I have it connected to the antenna on the radio in the hopes that some will leak through the antenna. The set is off. The power is on. So we should hear this thing almost right away, and the volume on this radio is a little high all the time. Let me just close my door here. Okay. Hey, I didn't mention, today's a big day here in my house. We're starting the day with two cats, one cat, Shadow, and we're ending the day with 3 cats. So, yeah, maybe tomorrow's video might include some more cats too. Uh-oh. Kittens. Okay, we're ready to go. I'll just flip it on. The volume's too high. My only option really is to try to cut back the signal strength. I can do that right now, in fact. That should be enough to do the trick. And we want this to be modulated here too. 1000 hertz. Okay, here we go. That doesn't pop in. There's no popping. Where's the sound? Oh, we got bigger problems today. It's 100 volts on the radio. Tuning it. Is it just because the signal generator's hooked up? I can hear a hum in here. Okay, well, let's assume everything's working and it's just 468 is not the IF frequency. So I'll tune this through it, and we'll see what happens here. Yeah, that's not very good. Yeah. What's going on with you, Mr. Radio? You don't seem to be working. Let's get it on the broadcast band. Okay, it's on the broadcast band now. Is it just because I've got the signal generator connected? Uh-oh. Oh. What just happened? What did you do to it? What's going on? Well, this is another fine mess you've gotten yourself into. Put the antenna on it. There's nothing coming out of the speaker. Worried about the pointer, and the radio stopped working. Why? What am I doing that's stupid? The humming got louder on this for some unknown reason. Jim, the radio stopped working. What'd you do? What'd you do, man? Tube, a loose tube? Okay, I heard that. I can hear it. Where's that local oscillator? So we think we're tuned, who knows where now. Okay, I'm going to get the local oscillator onto the SDR here. Okay, so you can see my SDR radio. The pickup coil is this guy. Let's just check. Yeah, you see the influence of touching it. Putting this right around the tube that easily worked last time, around the 1L6, and we should see the local oscillator. I'm on the broadcast band and tuned to the lower end somewhere, and so if we add 455 like to where it is now, that would be 1100, 1200, somewhere in this range is where the local oscillator should be, and that's certainly on the screen there. Let's tune the radio. There is no local oscillator. Well, it was working yesterday. What happened? Running the radio with 100 volts. That might be enough to do it. Let's jack it up to the proper voltage. I made a big difference on the radio. Now what about, where's the local oscillator though? What is going on that SDR? Okay, I think I might see the local oscillator amongst all this nonsense. I think it might be right here. Right there. 1130. So where is the radio tuned right now? So if the local oscillator is correct, or if the IF is correct, it's 455 below this. Let's just. Darn! I should just unplug the speaker. Let's go up here with it. Where is it? Man, there's so many things there. Pick your local oscillator. Maybe I get a better signal on it here if I just move this pickup coil a little bit. It should. I would want it to be leaping right out, like just jumping out of there. There's something jumping out of there. Here, this doesn't look like a good spot at all. Well, I think this is the local oscillator right here at 1200. Let's leave it there. So if you subtract 450 from that, you get roughly 800. So the radio conceivably is tuned around 800 where I put the pointer. Okay, so we can find that out by feeding 800 frequency into here. Okay, let's do that. This is a little high. A little high on the output. No, it's okay. Here we go. Do the thing. 800. Yeah. There it is. How come that didn't work? Because it's actually higher than 800. Then the easiest thing I can do is tune the radio down. It doesn't seem to make any difference to the sound coming out of the speaker, does it? I would guess the local oscillator is this one here. Oops. Get on there. Around 1120. So if at 1120, 455, the math is too complicated for me. A little over 600. So we're a little around 600. Gosh, what has happened here? Man, we're getting nothing anywhere. Let me whack it with a signal. Oh! It's possible. The reason is I don't have the signal generator connected. I got this thing hooked up to the outdoor antenna. Duh. Too many clip leads. Too many clip leads. Okay, let's try this again. This will make a little more sense now. I guess other people would edit their mistakes out, but of course I don't. Why is that? I'm stupid. Okay, ground. Signal 1. Okay, buddy. So we're right near the IF. I'm going to tune up through the IF. We might hear it, and then go up and find out what frequency we're actually on. Did not hear it. The IF. Go up now to 800. 600. So we're at 660. Well, that's not far from where the pointer's sitting right now. Just wondering what could have been done to try to compensate for this crazy problem. So we're actually, if it's 660, we're actually really close to 660 on the pointer. Why would I set it? I don't know. Just so at least something's adding up somewhere. Okay, so 660. So if you take 660, add 455 to it. Why do I deal with these difficult numbers? $660, which is the 664. 664. We want to add 455. And we get 1119. So the local oscillator should be at 1119. And where is it? It's at 1116. So you see, the local oscillator is a local oscillator, and the IF, they're all adding up here. This means the IF is tuned at 455. That's what we're close to it, very close to it. So there's nothing there. Now, what exactly is the problem? The radio is showing 660. It's receiving 660. The problem is it cannot go. What is the problem? The problem is I'm going to go way off on this side. That's not very far. What's the problem, chap? So picking that up with basically no antenna. Is the problem with this radio. It's a long journey. So we're getting at so that's the end of the road. This is the problem. The problem is you can't go any higher than that. Because this wheel has hit its stop. This wheel has hit its stop. What if I bend the stop out of the way? Let the capacitor be the stop. What if I bend that stop out of the way? It'd be this piece of metal here, not the pin, but the piece of metal bent out there. Well, it has a, why did they bother with this anyway? Most radios, it's just the capacitor that stops things. It reaches the end of the road and everything stops. Why have this one have a stop? If I remove the stop, or bend the stop out of the way, won't the pointer travel all the way? It'll travel all the way until this capacitor maxes out. Why would that be a problem? Would that be a problem? What were they thinking when they did this? Well, it's a great advantage to having this block stop in here. Is it possible it literally is just a place to mark the position of this wheel very, very firmly during the construction of the radio? So this wheel has to be in a certain position, so what you do is you put that in the right position, you put this wheel in the right position. How do you know this is in the right position? Because of that stop. And then you do the strength, and when you're done, the stop is fine anyway. So it's an aid in putting the radio together. Oh, I'm so good at making up stories here. Well, I have a solution. I am going to go and drink some coffee and think about this possible solution to the problem, because it sure is attractive. It is really attractive. Okay, let's pursue the get rid of the stop idea. There's two ways of doing it. One is to get rid of the this pin, and the other way is to try to bend the stop that it strikes. And I think it's pretty clear that bending the stop would be the preferred way to do it. It's pretty heavy material here. Not a lot of room to operate in there. Trying to bend this off or break it off, it's probably riveted on, and you end up distorting the wheel, and good grief. This, the only thing that can happen here is the piece I'm trying to bend will bend. Pretty sure of that. I got the tool to do it with, I think. Well, let's just see if it'll fit. I'm not going to bend it yet, I'm just going to put it in. Yeah, this is definitely the tool to do it with. Now, yeah. Okay, I'm gonna just drink a little coffee before I actually do this, because I think this is a one-way trip, and I don't think I can bend it back. Might be able to. I just have to bend it enough that that little stopper clears it, and then I think we'll have full travel of the string. I think this is the solution here. Okay, I walked halfway to my coffee cup and realized there's another issue here. So the strings are going to come out of holes here, and if those holes rise up beyond a certain point, we get in trouble. So hard to explain it more than that. So I'm going to put this down to the stop point, and then I'm going to look for holes. There's no hole near here. Gets the other. Here comes the hole. Here's the hole. So this hole, if this hole swings around and comes past where this string comes out, then we're in trouble. And I think that's exactly what's going to happen, because you can see where the hole is here. Oh, my good idea is going down the drain here. The hole is here, the stopper's there, so the hole is going to be by. It's probably going to be right just about as far as you can get it before it starts becoming a problem. So I'm going to put it there. Now we need this thing to go another 10 or 15 degrees of rotation here. Let me get the other camera going again. We'll take a look with that. The camera's looking at my new camera I just bought, the C922, which I'm going to be trying out later in hopes of getting a little bit of a better image. That's a slightly better camera than the one you're looking through right now. It's the same make. I'm not promoting this. That's what you're going to be looking through probably tomorrow when I get it set up. Okay, we want to observe the hole. This is going to be a little tricky, especially if I keep standing on the camera wire. We got to observe it coming up. We have to be able to see it. Can we see it there? Boy, I don't know. You can see it like that. Well, let's give it a try. Where am I now? I'm at the stop. So did the hole show up? That is the hole, right? That's the hole. I've centered the hole. So that's where it is, and you can see the string rising up, but that's not the string going in the hole. The string that's going in the hole is this one here, which you can't really see. This string is going in the hole. So we could move that hole how much further before we get in trouble? The other thing is, I think the like as soon as that string starts to pull straight from the hole, oh look, it's coming right now. That's the stop. Oh my gosh, we can't go any further, or that hole is going to pass. As soon as the hole starts passing the tangent point of the string, if you like, or where, the amount of string take up will change, and I think the string will start going slack, very, very slack. That's really too bad. Wow, well, it's a good thing I didn't do it. That's a good thing. If I bent this off, and it might have allowed the pointer to go a little bit further before the string hole rises up to meet the string coming in, and then after that it starts. Yeah. That's what I say. Okay. Coffee and think. Boy, I thought I had the solution. Man, I really did, but no. Okay, I got one gulp one gulp of coffee down, and So there's two strings on this wheel. Maybe only one of them is terminated on the wheel and the other one is just wrapped around. So that would make some sense. This one is, string is definitely terminated here. The in and out is terminated on this wheel. And it comes over to this wheel. They're going to terminate it here too? Probably not. This string comes to this wheel. It's got to terminate somewhere. It only comes to this wheel. So the terminated string on this wheel must be this one. And the terminated string on this wheel has to be the one that terminates here. That means I can slip the string for here on here. I can force it. Really? So let's look at the string diagram, because it'll be obvious on the string diagram what the truth is. Okay, so we latest production sets. Well, I don't know. We will start with this one. We want to follow this string. So it comes out, comes around. You know what? We got to start here. See the direction of the arrow? Comes out, comes around, comes down here. Oh, this is on the little wheel. Goes on the little. This is the one that's pinched in the middle. Goes around. I think it goes around twice, and it's a slack spring pulling on it here. And then it continues, and the end is over here. So this is slippable. This can be slipped if a couple things. Tension can be reduced in here. And, you know, chances are it's very difficult because this spring is designed to counter any attempt to reduce the tension in here. So to reduce the tension, you practically have to get a hold of this and pull it up. Pull this up, freeze this in place, maybe at the limit. Freeze if it can be done. It could be this opening's in a bad spot when this is at its limit. But we could do this at either limit. So we're at a limit. Let's say this wheel's at the stop. You reach in with the tool, reach in and grab this part of the spring and pull it. That's releasing enough tension. I'm holding this wheel in place, and then I'm over here forcing the capacitor into its proper position, causing the string to slip through here. There is no spring tension here. All the spring tension is here. Another way of looking at this is this got into this state somehow, and it must have slipped through here. So another way to reduce tension would be to instead of reaching down in here and trying to pull a thing, it's just to take this. Well, so these guys here, you can pull the string off them and lay it on the shaft in behind. You don't have to pull it off and have it fall down. You can lay it in behind. And this takes a little bit of tension off. Probably not enough to do the trick though. Plus, if this is in a particular position, then tugging on these strings tugs all the way around is pretty tough to tug all the way to here. If this is in the right position, whatever that might be, then tugging on these strings would have an easier time pulling this. Why do I want to tug on the string and pull this? That doesn't make sense, actually. I don't want to tug on the string. I want to do the opposite. I would want to I could grab both these strings at the same time here and push them both towards the big wheel and take the strain off. And then we have to hope the string is going to slip around through here. And how's that help? I would have to have this in its, well, this can't reach closed in one direction, but this reaches closed in the other direction, and then this has farther to go. That's probably a better way of doing it. Put the capacitor, in this case it would be closed, totally closed. Then the stopper will stop short you know, the pin will stop here and the block is here. And all I got to do is advance this to the block by slipping this on the string. Some of these guys, when you turn them in one direction, they clamp down on the string, so to speak, or the friction or the hold is increased. And when you turn it the other way, the opposite happens. The hold gets looser. It doesn't seem to lead anywhere, but well, that seems to be the best idea. My best idea. Turn this until it's closed, and then try to advance this until it hits a stop. And if I can do that, the job is done. And I could potentially, maybe, reach in and get this. It depends upon the position of this wheel. Okay, let's take a look. I got a plan. I got a plan. Okay, everything seems so simple now. Let's, here we go. I should have done this before I started the video. Go to the other side till the capacitor hits the stop, its own stop. There we go. And there's still room for this guy to go. And it gives you an idea of what would happen if the stop here wasn't there anymore. That may not be necessary, right? That's right. I don't need to get rid of the stop here. I need to make the string slip on here. That's this string. Yeah. So this would be involved in pushing this wheel forward now until the stop hits. Is there any chance of that happening? Without breaking the string? So sometimes on these, when you're fiddling around with them, you'll build up tension in part of the string system. It'll be trapped in part of the string system. But if you just turn things a little bit, then the tension will even out, if you like. So while I'm doing this, I need to do that a little bit too. Did I get anywhere? Well, you know, I can check because we're moving the pointer. So let me slide the pointer back this way. Look, it's heading back to this thing. So right now the pointer is ending at, let me use this number down here, 58, 580. So now I'm trying to push this wheel. I don't know, did I get it anywhere? Not really. Feels like it's working, but I should not be able to move the pointer. Yes, it should. Yes, it should. Yes, it should. Yes, it should be moving the pointer if it's slipping. So it's not slipping easily anyway. So now we'll try to peel off the tension. First of all, the hole to go in, and yeah, you know, that's on that little wheel inside. There's no chance. I can actually see the hole, but there's no chance of going in and hooking anything. So we want to take the tension off. So one way would be to grab the two strings and pull them this way a little bit, and then try to advance this. So the two strings which are heading downwards are these two. I could pinch them right here. And what would I pinch them with? I want to pinch them with a tool. And I want to cut them. You got to pinch them and hold them tight with some kind of tool that won't damage things. Well, I don't know what that is. just take the biggest thing I've got here. So I'm going to want to pinch them, and then I'd want to hold it with my hand and try to, I'd like to have this up against something, so pinching them right here would be good. Except I'm going to be squeezing this. I'm going to be building the tension. I don't want to build it. I'm trying to release the tension. No, that's no good what you just said. I'm trying to release the tension. So it would be great if I could grab it and lever it like this. That would be great, but what do we got to do that on? The antenna. I don't like that idea. So we just have to do it by freehand, which I don't like either. Well, let's see. Maybe this is easy. Maybe this will go easy. We'll give it one try here. Okay, grab the strings. Now I gotta try to pull off the tension and spin the wheel. Doesn't seem to be working at all. Break the string. Well, if I break the string, then I'm forced into the whole string job. So I mean, that's kind of where I'm heading anyway, it looks like. That's not working at all. That's something wrong with that idea. Something wrong with that. So going back to trying to grab the string and pull its tension up, I could do it perhaps. I'd have to take this off, get it out of the way. That's probably what has to happen here. It's probably at this point the easiest way to go is to remove the front now. So if you take the bezel off, nothing will happen at that point. That'll expose the this. We can hopefully lift this up or somehow get this off the of here, because this is going to go. Still leaves a board down here. There still is a board. But it looks like it exposes enough of these wheels that if I have to get at them. What about this whole mechanism? So, oh my gosh, so this part of this mechanism is attached to this panel. The other part is attached to this bracket. So I have to release this screw, and then this whole thing is just kind of hanging here. It's got two screws holding it here, so it probably wouldn't go anywhere. Take this plate off, then I have access to the wheel here. And I can really release the tension and get the slip happening. That looks like that's the way it has to go. Now I'm going to take the bezel off to get the glass off, because I got to clean this anyway, and that's the only way to do it, I think. So, okay, it's nice and slow and steady when you're ready. I don't know why I said that, actually. Let's do these two now. Ever done something and when you get it all done you go, oh, if I'd only known. That worries me a lot in this kind of work, that you know, there could be two ways of doing something, a real simple way and then a long complicated way, and if the first one you think of is the long complicated way, look out. Gonna come off now? Yes, with the glass. Beautiful. Okay, this is off. I'm gonna put this in a safe place. And it's not in my shop. And we'll be able to dust this, which is really valuable. So now this plate is held on with 4 screws and one more on the back here, this guy. And then that plate will come off, but only if we get this off. Can we get this off? Yes, easily comes off. It's not a deal, not an issue. Okay, I think the only way forward, on this, and at this point I'm beginning to risk this radio. This radio's got Roberts screws in it? It does, it's full of Roberts screws. This must have been made in Canada. Huh. Okay. Because I'm pretty sure if this was made in the States, these would all be Phillips style screws. Okay, that guy's out. Short screw, one of a kind. Take these guys out of here. These four, that looks like smaller than a green. No. Oh, don't do that. I guess I have this plate right off. I'll be able to clean it even easier than having it on the radio, I guess. This is the point where I start thinking now, what didn't I think of that I'm about to crash into? You know, that's a symptom of first time through. Like, you know, and I said before, there's always a price to education, and I could be paying it right now. This is going to drop right off if I'm not careful here. Let me hold it in the middle. Why you're not okay? What did I not think of? Good, nothing. There we go. Okay. Now we get a much better view of things. So maybe I was overly hesitant on doing that step, because now we can really see this guy. Let's turn this way. Hapless pointer. So, if I look down in there, you can see, just as the diagram showed, the spring pulled fairly tight. And what I would want to do is, one way is to pull that to release the tension and then slip the wheel. And now the radio is not in a position where I know how far to slip the wheel. I don't have to guess. You do repeated guesses and get it close. And the last part is just putting the pointer on the string. Does it have to be exactly right? This isn't tuning anything. It's gearing something though. But does that matter? I don't know. Let's try. So I have a particular tool that I use in these situations. If I can find it. There it is. I call this my string tool, my pusher puller. So on one end I bent it into this shape, and the other end's just a hook. I'm going to use the hook. I'm going to try to, first of all, see if I can even do this. Can you even do this? Go in and pull on that. Oh yeah, that's easy. That's easy enough. I can actually do the slipping now. I could do the slipping if the capacitor were in a stuck position. It's not. But when I turn this thing, let's just see, maybe I can I get too excited to finish my words. Maybe I can get at it down here. I can get at it this way. Okay, so we'll go right over to where it's stuck. Okay, so the capacitor is now stuck. And I can easily pull on this. And then the idea is to slip it all the way until the stop hits. That's the plan. Okay, easily pull on this, he said. He said something about it being easy. Let's go in here. I got it. Okay. to do is pull on this and then force this wheel. Come on, wheel. What's going on? As they force the wheel, why are you fighting me so much? Don't fight me, man. Are we getting anywhere? Am I breaking something? Oh, we gotta do this. The disturbing noises are just this thing banging away here. Don't pull it out so much you lose it. Where are we now? We're getting there. We're getting there. I think I'm hitting the stop. Almost. That's a stop. Okay. Now can I get this out of here without breaking the string? Yes. By Jove, I think he's done it. Interestingly enough, the tape is indicating the right position for the pointer now. Yeah, this is the drop on this radio. Holy smokes, man. Okay, so we're hitting a stop here. Capacitor is all the way open. We're banging the stop there. Now we're going to go back all the way. By Jove, I think he's done it. This would be the moment where the string breaks. That would be good. And there we all the way. Coffee reward. Okay, so I'm going to take a guess that the pointer was actually in the right spot, and this tape is actually marking the correct spot. Is that another spot where I'm going to break the string? No. Okay. Don't know that that's right, but probably is. So I have a chance now to take a look at this mechanism, which is sticking. So when we do the band change, this thing doesn't always move. You can just see all the corrosion that's developed in here. So it has a spring in it. I don't know why you would really want a spring there, but the spring is allowing this to. Oh, it's really gooey. Does this have a dried lubrication on it? Doesn't really feel like it. So what would you do with this? All that corrosion on there. Most of it is immaterial. It's just the part right along the sliding edge here. Why don't I just kind of clean it up a little bit and maybe put a little bit of lubricant on there. Now, the problem with the lubricant is it kind of wanders, and it can come out the front here and start showing oily stains. There's no lubricant on it now. In fact, these little screws are spring-loaded. That's part of what's going on here, because the spring is causing this to kind of clamp down on this piece of metal. So just cleaning this up may be just enough. So I am going to do that. Just so there's no... Yes, cat. There's no mystery of how I did this. This is how I'm doing it. At least to start. You can see the loosely adherent corrosion product floating away. Let me change bands here. Other way. Let's go the other way. I think we're going to need some lubrication on this. The tiniest amount. Get it sliding properly. Let's see. Looks better. That's much better. You can see the spring is not being stressed out. Oh. Oh. It's not happy going the other way. It's kind of like a rubber or plastic material up against metal. I think the tiniest amount of lubrication is going to help. So let's try that. Tiny amount would be with this stuff here. This is just some synthetic grease. I just want to put just the tiniest amount on. Not on the string. Let's see what that did. This is where it has trouble. Better, no doubt about it. Back and forth a few times, it'll it likes going in one direction. Not bad. That's probably about as good as it's going to get. I only got the grease on this side of the metal. Put a little more on. This time we'll do it with a tool here. Big moron and a little moron are sitting on a cliff. Suddenly the big moron fell off. The little moron didn't fall off. How come? Because he was a little moron. That's about the extent of my joke telling, by the way. There's not much more in my joke kitty than that. Okay, let's try again. There's a reason why I don't tell jokes, because I'm terrible at it. Okay, this way is the way that it's getting there. Yeah, it gets there. Okay, we can't do much more than that anyway. Very good. While we're lubricating things, let me get the WD-40 here. We're going to lubricate these ball bearings. And it's probably not worth doing this, but I will. I already sprayed these guys with the cleaner. Dust right there. Ball of dust. Just blow it elsewhere in my shop. Okay. So the situation would be now, I'll be able to align this radio properly, and with the pointer in the right spot. But I'm going to do that tomorrow because this is good enough for today. I have a success in hand. I'm going to go enjoy my day knowing I had success in here. So thanks a lot for watching, and we'll carry on tomorrow. I'll probably just complete the alignment. There still are old components on this radio I haven't changed yet. So it would be like a rough alignment, and then we'll look at the component situation underneath, see what we think needs to be changed at that point. And we're almost done. Fantastic. Well, thanks a lot for watching, and I hope you get a kick out of my videos, and we'll see you tomorrow.